Hi, I'm Greg, and we're going to look at the Pythagorean identity now. So, started by drawing theta on a unit circle. So again, the unit circle means that I have a radius of 1, and so theta rotates up, and the terminal side is here. Now remember that the point here, the coordinate, represents the place where the terminal side of the angle intersects a circle with radius of 1. And we've got cosine theta, sine theta is the coordinate. Now, one thing to think about is that really, if I drew straight down and straight over, I can form a triangle. And the length here is x, and the length here is y. Right? This is the whole idea of the unit circle and relating the x and the y with cosine and sine. But this is a right triangle. And one thing we know about right triangles is that in a right triangle, a squared plus b squared equals c squared. So in this triangle, one of my legs, the length is x. One of them, my length is y. And then my radius in the unit circle is 1. Now another thing we can do, because x is the same as cosine of theta, x squared, well, that's the same as cosine squared of theta. And because y is the same as sine, then I can replace that with sine squared. So cosine squared plus sine squared equals 1. This is, because it's so related to the Pythagorean theorem, this is called the Pythagorean identity. Okay? So cosine squared plus sine squared always equals 1. Typically, it's written sine squared plus cosine squared equals 1. Other ways you might see it, if I subtract sine squared from both sides, cosine squared theta equals 1 minus sine squared theta. This is very helpful in identities. Same with sine squared theta will also equal 1 minus cosine squared theta. So how can we use this? Well, if we're given cosine theta equals 2/3, and because of the squaring, it's also important to know where the terminal side of the angle, which quadrant that lies in. So here, the terminal side of theta is in quadrant 4. That's a 4, trust me. So what I'm going to do is I'm going to do a little sketch. So I know that theta is in quadrant 4 somewhere, and that cosine theta is 2/3. So this length here would be 2/3. And so I'm looking for y, which is also sine theta. So I'm going to use my new Pythagorean identity to do that. So sine squared theta plus cosine squared theta equals 1. I know that cosine theta is 2/3. I'm going to square that. Now subtract from both sides, 4/9. So sine squared theta equals 1 minus 4/9, which is 5/9. Now I'm going to take the square root of both sides. Now because I took the square root of both sides, this could be positive or negative square root of 5/9. I'm going to simplify that because the denominator is a perfect square. Square root of 5/3. Now, which is it? Is it positive square root of 5/3 or negative square root of 5/3? Well, I'm given that the terminal side of this angle is in quadrant 4. And in quadrant 4, because sine is the same as y, and y is negative below the axis, then I know that sine of theta is going to be the negative case here. So sine of theta is negative square root of 5/3. There are a few different ways, given one trig ratio, to find other trig ratios, but this is definitely one that's very easy.